Oh, let's do this to make sure you guys can see here. All right, so today we're going to talk about standard deviation, or measures of variation, actually. Okay? All right, so I'm just going to open up a blank spreadsheet here. And let's pretend you want to buy 2 potatoes. You go to farm A and you go to farm B. And farm A, you buy two potatoes. One of the potatoes weighs 4 ounces. One of the potatoes weighs 6 ounces. This is in Idaho. In fact, here, I'll change this. This is the Idaho farm. And then you go to the Las Vegas farm. Buy 2 potatoes. One of them weighs 1 ounce. One of them weighs 9 ounces. Okay. Now, I'll bet without too much thought, you can probably tell me what the mean is, or the average potato size. And I'm going to pick on Jordan. Yeah. What's the average potato size in Idaho? 5. And the mean in Las Vegas? Is also 5. So would you agree that there's no difference in potatoes whether you buy them in Idaho or Las Vegas? You would not agree with that statement. How come?
There's a huge variation.
Yeah, so there's a lot more variation in the Las Vegas farm than in the Idaho farm, right? Everybody agree with that? Okay. Now, one way to measure the variation would be a simple calculation we would call the range. Okay. So the range in Idaho is 4 to 6 ounces, which is a range of 2. Okay, 2 ounces, right? The range in Las Vegas is 1 to 9 ounces, which is a range of 8 ounces, right? Okay. All right, now, what if, here, let's add a third potato in the mix. If I add a potato, let's make them both 5 ounces. I had a 5-ounce potato in Idaho, a 5-ounce potato in Las Vegas. Neither my range nor my mean changed at all, did they? Okay. So, would you say, though, that there's... So range isn't a very, what's the word? It's not very... it doesn't change very much, even though we added a change in there, right? It's not really super accurate. Okay, so, and besides the fact this is Math 2040, we got to come up with something way more complicated than range to calculate variation, right? Okay, so I'm going to give you 2 formulas. How we're going to do that is we're going to do that with the standard deviation. Okay, so this is section 3.2. It's actually called measures of variation, but we're going to talk mainly about standard deviation today. Good thing I turned my thing on there so we can see that. Maybe I'll turn on the light too. All right, so there's actually 2 standard deviation formulas. One of them is sigma equals xi, the sum of xi minus mu over, let's see, squared over, sorry, the whole thing over n. Let me make sure I'm doing that right. Sorry, I'm going to make a capital N. Okay, this is what's known as the population standard deviation. Oh, and I forgot my square root on here. Okay, this is your population standard deviation. Your sample standard deviation is a very similar formula. It's going to be S equals the sum of xi minus x bar squared over n minus 1 square root. This is your sample standard deviation.
Are what was that? Some xi.
X sub I minus X bar over n minus 1. Okay, by the way, this is the letter sigma, this is also the letter sigma. Those are both the same letter. Okay? It may look Greek to you, right? Okay, it is. All right, so now, which formula are you going to use? Most of the time, you're going to use this one here. Okay? So it all depends on what we learned in chapter 1. Am I dealing with a population or am I dealing with a sample? Now let me ask you a question. On the test next week, by the way, we got no school on Monday. Did you know that? Sleeping in on Monday, that's going to be nice. Test next week, probably, I think it's going to be Wednesday and Thursday. I think I'm going to have a review day. I usually don't do a review day for the first test, but I think I'm going to change my ways. So would it be possible for me to be able to find the population standard deviation of this class? Okay, it would, right? So which formula am I going to use for the population standard deviation for this class? I'm going to use the top one here, right? The bottom one is going to be used more often because most of the time we're not going to be dealing with populations, we're going to be dealing with samples. Okay? Now the reality is, if you have 1,000 in your population or you have 999, these numbers aren't going to be very different. It's only going to be different if you have a small number. Okay? So, so this is the one. So when you're reading your problem, that's why chapter 1 is so important. When you're reading your problem, you have to decide, am I dealing with a population or am I dealing with a sample? Okay? Most of the time, that's why I put the star here, you're going to be dealing with a sample. So this is the formula you're going to use most of the time, but you could use the top one. Okay? So what I'd like to do is I'd like to come through here and I'll give you some steps. Steps to follow. Okay? Now, we're going to use the Greek letter mu when we're dealing with a population mean. And we're going to use this X bar when we're dealing with a sample mean. Okay? Now, to be honest, you're going to figure those out the same way. The formula for each of those, you just add them up and divide by the total, okay? Okay, so the first step you're going to do is you're going to find the mean, okay, of your data set, okay? The second step, as you look here, you're going to find the data minus the mean, okay? So we just follow our order of operations here. X sub I represents each data point. So you're going to take your data and you're going to subtract your mean. Then what is this telling us to do? So step 3 is to square the difference. Step 4, what does this mean?
Sum it all up.
Find the sum. Find the sum of the squares. And then we're going to divide by n or n minus 1, depending on how do you know whether to divide by n or n minus 1? You have to decide, am I dealing with a population or am I dealing with a sample? And then, oh, by the way, this step here, we'll star by it. This step has a special name. It's called the variance. Okay? In the future, we're going to do a test called the analysis of variance. Sometimes we like to deal with the variance rather than the standard deviation, but the last step is take the square root. Okay? So here's the deal. On the test next week, I may or may not give you a formula sheet. I'll probably give it to you. Okay? So I will give you these formulas, both of them. Okay? I'm going to give you probably every formula you're going to need for the rest of the semester on the test. We'll just reuse them over. But I'm not going to give you these steps. Okay? Now, back when I was in school, we didn't have computers. And my teacher made me figure this out by hand. I'm going to let you use the computer to figure it out. Okay? So we're going to do that right now. And in fact, I'm going to do this both ways just so you can kind of see the difference. Okay? Now, to kind of understand standard deviation, what I'd like to do is, let's pretend we're going to go back to the farm, and we're going to buy 5 potatoes, 1, 2, 3, 4, and 5 ounces. Okay? All right, so we've got 5 potatoes. Now, step number 1 says, step number 1, find the mean. Now, I'll bet that somebody's pretty smart. I'm going to pick on Shelby because I remember your name. 1, 2, 3, 4, 5. Can you figure out what the mean is? 3, it happens to be the median as well. That was nice, right? You get picked on first, you get the easy question. Okay? All right, so we found the mean. The mean is 3. Now we need to find the data minus the mean. Okay? So here's what we're going to do. I'm going to take the first potato, which is 1 ounce. I'm going to subtract off the mean. Now, my question is, do I want to F4 either of those numbers? Okay, is it Josh? Josh, which number do I want to F4? The mean, the second number. So if I press F4, that F8 is not going to change. Okay? All right, so if I press that, so 1 minus 3 is -2. I'm going to copy and paste that down. And so I've just completed step 2. So step 2 was data minus mean. Step number 3 is to square the difference. Okay? So then I'm going to do the difference raised to the second power. So I'm going to take this -2. I'm going to do shift 6, which is the caret key. So -2 squared should be 4, and if I did it right, it is 4. Okay, now do I need to F4 that one, by the way? No. Okay? I'm going to copy that down. -1 squared should be 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. Okay? All right, so I've squared the difference. Now, step 4 says find the sum of the squares. Okay? And I remember that I've got this cool button here, and I'm going to sum that right there. It's going to say, is that what you want to add up? And I'll say yes. That is. Oops. You're supposed to press enter before you move that around. Okay, so the sum is 10. Now I have to, I'm going to do this both ways. I'm going to do the population variance, and I'm going to do the sample variance. Now we have to decide, am I going to divide by 5 or am I going to divide by 4? Let's pick on Juan. What do you think?
The population.
Well, I'm asking. If these are 5 potatoes, am I using a population or am I using a sample?
Sample.
I'm probably using a sample, right? Unless you got a really small farm and all you got is 5 potatoes. That seems kind of weird though, right? Okay, so more than likely I would divide by 4. I'm going to do it both ways just to show you what the difference is. Oh, you know what? I forgot to ask you guys a question. Here, before I do that, I should have asked you a question at the beginning of here, okay? I want you to guess what the standard deviation should be, okay? If 1 to Actually, let's look at this column. If you were to guess without doing any math, just in your head, what do you think the mean of those numbers would be? We'll ignore the negative signs for now. What do you think, Jay?
What was the question again?
If you look at those numbers I've just highlighted, we're going to ignore the negative signs for a moment. Okay? 2, 1, 0, 1, 2. Don't do any math, but just tell me what you think the average of those numbers would be, approximately.
About 1.
Between 1 and 2, probably, right? 1.5? Okay? That's actually a really good guess. Okay? All right, now, the question is, we have to decide, is this a sample, is it a population? It's probably a sample. So I'm going to take the 10, I'm going to divide by 4, which is going to give me 2. I'm also going to pretend that it's a population just so we can see what the differences are. 10 divided by 5 is 2. Okay, so you can see there's a slight difference depending on whether I assume this is a population versus a sample. Okay? All right, your final thing is we're going to do the population standard deviation and the sample standard deviation. Okay? So the final step is it Mitchell?
Yeah.
Okay. What's the final step?
I don't know.
You don't know what that stands for?
I actually can't see that.
Oh, you can't see?
No.
Oh, you
Not that well.
need glasses?
Yeah.
Okay.
Yeah, I do.
All right, it says take square root there. Okay. So I'm going to take the square root. Now the square root command is equals sqrt. And I'll do the first one. So if we assume this is a population, okay, now Jay guessed that our standard deviation was about 1.5, 1.41. That's pretty good, right? And if we assume it's a sample, the square root of 2.5 works out to be 1.58. So you can see 1.5 was a pretty good guess. Way to go, Jay. Okay. All right. So does that make sense? Now on the test, I'm probably going to give you more than 5 numbers, but I will make you figure this out by hand. Okay. This will be a computer test. Now, by the way, we have Microsoft Excel. Do you think they would know? Do you think Bill Gates would know how to find the standard deviation in a much easier and faster way? Is there a shortcut? Do you know what the shortcut is? If you were Bill Gates and you were going to come up with a command to find the standard deviation, what would you call it? stdev. How about that? Okay. Now, can you use this on the test? Only if you want no points. I'll let you check yourself, but you're not going to get any points for checking yourself. STDEV. Oh, what do you think the dot V, excuse me, what do you think the dot P and the dot S means? Population and sample, okay? Let's pick the population here. Now it says put in number 1, number 2, number 3. You can highlight your data, and we're going to find out if this gives us 1.41. About that. We're also going to do it again. We're going to assume it's a sample. We're going to highlight this. Is it going to give me 1.58? This. How many points do you get for using that command? 0. But you should, if you want to check yourself, you should be able to walk out the test and know if you did it right. Okay? So you still need to go through the manual steps on the test to get all the points. Okay, does that make sense? Okay, yes.
Well, this is how you find standard deviation, but like, what is standard deviation like telling us? Like, what does that number mean?
So remember we talked about the range. There's a range of 2 here and a range of 8 here. Another way to think of the standard deviation, kind of a better definition, is the average, and I hate to use that word, but I'm going to say the average distance from the mean. Okay.
All of the numbers.
For all of the numbers. So the average distance for the mean is about 1.5 in either case. Okay? That make sense?
That does make a lot more sense.
Yeah, so that's what we just did. So we figured out the standard deviation. Now, the next question is, you'll probably ask me, why do I care what the standard deviation is, right? Is that what you were thinking?
I guess it kind of makes sense.
Kind of makes sense.
How I spread apart everything.
Yeah, it's a measure of variation, okay? So now the question that you may say is, why do I care, okay? Well, as you all know, we haven't talked very much about the normal distribution just yet, but let me tell you, you're probably all familiar with the bell-shaped curve, right? Okay, so this is what we're going to call the normal distribution. Okay, it's the most important distribution in all of statistics. We use the normal distribution even if data are not normal a lot of times, because a lot of data can be simulated with the normal distribution. Okay, the normal distribution has a mean, mu, and it has a standard deviation, sigma. Okay, this would be 1 sigma, and this would be -1 sigma. Okay, so there's 3 rules here. We're going to call this rule the 68, 95, 99.7 rule. Isn't that a great name? Okay, and what it says here, rule number 1 is that 68% of your data are between -1 sigma and +1 sigma. Okay? Rule number 2 says 95% of your data are between, what do you think? Say it again? 2 standard deviations, -2 sigma and +2 sigma, okay? So the idea here is 68% of my data are within 1 standard deviation if your data are normally distributed, okay? Rule number 2 says, if I go from +2 sigma and -2 sigma, 95%, this area here in green, 95% of your data are within 2 standard deviations, and I'll bet you can figure out what rule number 3 is. Tell me your name in the back.
Jeff.
Jeff, I'll bet you can tell me what rule number 3 is. No? You're not seeing any sort of a pattern with the name of the rule here?
99.7.
99.7% of the data are between, what do you think? Are you having problems seeing the board too?
A little bit.
You shouldn't sit in the back. It should be like Mitchell and sit in the front. Okay, I went 1 sigma here, I went 2 sigma here. What do you think I'm going to go here? 3 sigma, -3 sigma and +3 sigma. Okay? All right, so -3 sigma to +3 sigma, you've got 99.7% of your data. Okay? So the idea here is the normal distribution can be defined by knowing 2 numbers. Your mean, which is we're going to use as either, well, we're going to use mu for the population mean and sigma. If I know my mean and I know my standard deviation, which we just learned how to calculate standard deviation, I can use the 68, 95, 99.7 rule. Okay? Now, the next question is, what if the data are not normally distributed? Okay? because not every distribution is normally distributed. Let's pretend our data looks really crazy. It looks like this. Okay? Would you say that data looks normally distributed? Okay? It's not. Okay? It looks really terrible. Okay? So we have a rule called Chebyshev's inequality. Okay? What Chebyshev's inequality says is, make sure I get this right. For any distribution, at least 1 minus 1 over k squared times 100% observations are within k standard deviations. Okay? And k has to be greater than 1. Okay? All right, so let's pretend that this number here is my population mean. Now, I'm going to have a lot bigger standard deviation with this than I am with this, okay? So let's say I go out here at 1, minus 1 sigma, minus 2 sigma. Positive 1 sigma, positive 2 sigma, okay? Now the question is, how much data is within 2 standard deviations in this, okay? So the idea here is, so I'm going to follow. Now, if it's a normal distribution, we know that 95% is within 2 standard deviations. But if it's not normal, I'm going to do 1 minus 1 over 2 squared. 2 squared is 4. So 1 minus 1/4 is 3/4, right? If I convert that to a percent, that says that 75% of my data are within 2 standard deviations. Okay? If we compare that with here, you can see that within a distribution like this, I'm going to have a lot smaller number than 95%. So within 2 standard deviations, if it's normally distributed, I'm going to get 95% of my data. If it's not normally distributed, I'm going to get at least 75%. Okay? So that's why standard deviation is important. Okay? All right, so quiz tomorrow is going to be on 3.2. And we'll see you all tomorrow.